Welcome back to the VLM and VPX video series. Here we are at video number 4. We're going to talk all about flashers. The objective of this video, like the others, is to describe how to control flasher light maps using VPX light objects and some special scripting that we'll talk about at the end. But first, I'll describe what flashers are and how to hook them up on the table. Well, here we are back at our favorite demo table, Godzilla. Before we get into it, let's just look at a couple flashers. There we go. This is a flasher dome. Flashers aren't necessarily limited to domes. They can be in the playfield, they can be under plastics, or pretty much anywhere on the table. So this one is a dome. Let me show you one that's in the playfield here. So that's a big flasher under that giant insert. It's not an insert lamp in this case. That is a flasher. Flashers are usually really bright lights that turn on and off quickly on the pinball machine. In the context of VPX, we say they are solenoid driven, meaning that they can be controlled using a solenoid or a relay. But really, they're not limited to being controlled by relays. They can be controlled by transistors, so the lights can be pulse width modulated, which means you can control how bright they are using the pulsing of a transistor. Let's take a look at the Godzilla manual. All right, here we have the coils chart. So this includes all the solenoids in the system, and it also includes the flash lamps. I think they're grouped together because they're controlled in a similar way. The flash lamps are identified by number, usually, like 18, 19, and 20. But in this case, they're also identified by this F1 through F8 number. We'll go into how VPNMAME identifies the flash lamps in just a minute. Another important piece of information in this table is the identification of which bulbs are being used in the flash lamps. So in this case, it's the number 89 bulb is used for each flash lamp. This will become important in the script you'll see in just a minute. Okay, let's get into the table here. I'm going to turn on the flasher inserts layer and the flasher domes layer. So these are all the flasher lights on the table. They're all set up the same way. And so I'll go over one of these. This is a flasher dome. Like all the other lights on the table that control light maps, flasher lights are going to be hidden. We can still enable the reflection on the ball from the flasher lights. And if the flasher dome, say, is above the playfield, you probably want to increase the Z position of the flasher dome so that the ball reflection is calculated correctly. The intensity, the color, and the fall off range and power all have an effect on the ball reflection. It is also true that you need an intensity that's greater than 0 in order for any light to work with light maps. So that's for flashers, that's for GI, and for insert lamps. If the intensity is 0, the light maps just won't work. So make sure it's at least 1. Now for flashers, if they are PWM controlled, which they are in the case of Godzilla, then we want to have the fader be LED. This seems a little counterintuitive. LED just means that there's no fading function applied to the lights. But PWM flashers are still going to be faded through VPNMAME. VPNMAME is completely responsible for calculating the brightness of the flasher. And so we'll need to configure that in the script. But at the table level, make sure that for PWM flashers, the fader is set to LED. Now when it's set to LED, the fade up and fade down times don't really have any impact. So those numbers don't matter. Let's take a quick look at the light maps for this flasher. This is flasher F18. I'm going to filter on that. And here are all the light maps. If I just click on one, you'll see that the light map property is F18. So this indicates that the F18 light object will be controlling this light map. And that'll be true for all of these light maps. This will be automatically populated by VLM when we export the results from Blender to VPX. If it's not populated, that typically means that Blender was not set up correctly to point to this light object. And if there's nothing set up in this field, the light maps just won't work. That pretty much covers the table level setup for these light objects. Before we get into the script, I want to say that not every single table is able to use this PWM flasher setup technique. The latest version of VPinMame is 3.6, and the latest betas of 3.6 support this PWM flasher technique, but not for every single machine. Some machines just don't have PWM flashers, like some older ones have flashers that are relay driven. And some newer machines, like say Capcom machines, are not supported by VPinMame yet when it comes to PWM flashers. This list is the current list of supported machines. And before we get into how to set up the PWM side of flashers, let's do the simpler case where we're just going to use flashers that turn on and off and they don't fade. To do that, let's take a quick look at Break Shot. Break Shot is a Capcom table. It actually does technically have PWM flashers, but VPinMame doesn't support it yet. So from within VPX, we treat these flashers like as if they were driven by relay. Break Shot only has one flasher on the table. And these are the control lights for the flasher, these two white lights here. Because it is not PWM'd, the fading function for this is set to incandescent. So that means when these lights get a command to turn on and off, we allow VPX to calculate the fading function because VPinMame is not doing it for us in this case. Now these lights are called S128A and B. If we go over to the script, you'll see a subroutine here called Flash Light. And all it does is it passes the state argument into the state property of these two lights. So this flash light subroutine is being called whenever the flasher is turned on or off. So how do we make that connection between the ROM and this subroutine? Well, the connection is made through an array called the Sol Callback Array. The Sol Callback Array is a list of subroutines that get called by the ROM whenever the solenoid state changes. So for solenoid number 28, that's the solenoid assigned to the flasher for this ROM. So in Sol Callback index position 28, we assign the flashlight subroutine name to that position in the Sol Callback array. When the ROM actuates the flasher light. It calls this subroutine and it passes in a parameter that's either true or false. And that's the parameter that gets pushed into these states. So this is our interface with the ROM, the Sol callback array. And we'll be using something similar to that when we're dealing with PWM flashers. Let's just take a quick look at this table, and I'll turn the flasher on and off to show you what it looks like. So let's simulate what the ROM would be doing to turn this flasher light on. So I'll be calling the subroutine flashlight and passing in a true value. Okay, there it is. So this is not a flasher dome. These are just bright lights that are on the table in this position behind the centerpiece. Let's turn them off. You can see that it faded in and out, and that's because we're using the incandescent fader. Okay, back to Godzilla. Let's get these PWM flashers working. The very first thing you have to do for the PWM stuff is you need to set this constant. Use VPM mod sol equals true. So let's make that a little bigger. All right, there it is. And you have to do this before you load vpin main. So down here is where we load vpin main. I would recommend when you load vpin main and you're using this new technique for the PWM flashers that you pass in this argument to load VPM. This basically tells VPX to force the user to use vpin main 3.6 or higher. Okay. Okay, well, here we are at the Sol callback array again. Now notice that for the solenoids, we're still using Sol callback array, but for the flashers, we're using something different. It's the Sol mod callback array. Mod is short for modulated, which is just another way of saying PWM'd. So here's our list of flashers. We've got quite a few on this table. And you can see how the subroutines that control the flasher lights are assigned to each index of the array. Let's jump down to one of these subroutines, flash 07. The important part to notice here is that what's being passed into the subroutine is not true and false like it was with just the regular Sol callback array, but with the Sol mod callback array, a value between 0 and 255 is being passed in. In VPX 10.8, we can assign a value between 0 and 1 to the state of a light. And so that's how we are commanding the light brightness in this case. So we're taking the argument, which is from 0 to 255, dividing by 255 to normalize it between 0 and 1, and then passing that normalized value into the light state value. Doing this will modulate the brightness of the light and therefore the brightness of the light map. Okay, there's one more detail that we need to talk about that allows us to use this new PWM technique. vpin main calculates the fading function for us. So it is outputting this value between 0 and 255 based on a physical model of how a particular light bulb will react to a pulse width modulated signal coming from the controller. So vpin main has to be aware of what device is connected to the controller in order to properly simulate the physical response of the light. We configure vpin main to tell it what bulb type we're using on the table by passing the bulb type into an array called SolMask. SolMask is an array in the controller, and its index is related to the index in the solmod callback array. So like index 1007 corresponds to the solmod callback array position 7. 1018 corresponds to position 18. So you can see the pattern there. And the bulb type that we pass in is defined in this table up here. There's a list of constants, but what matters is that you pick the right one that corresponds to the bulb that you want to model. So in our case, we're wanting to model the number 89 20 volt DC bulb. So that's defined up here. And we just pass that bulb type into every one of the sol masks, because in our case, we're using bulb number 89 everywhere on our table for Godzilla. So this is being done in a subroutine called init PWM, and init PWM is just called from the table init function. So here we've got table 1 init, and init PWM is just down here. And that configures vPinMame for the bulb that we're interested in modeling. Well, I think that covers flashers. So up next, we're going to get into something totally different. Movables. I'll see you soon.